the panel discussion. So I invite all the speakers to come back. So Darwin, your last remarks, I think it opens up a good question to do a panel discussion. So you mentioned about these modular devices that are morphologically, very simple, but like contextually relevant, right? And then that gives, it's a nice opening for the sense of agency Kenji was talking about, right? So, and then Etienne was talking about this prediction, right? So we just don't want, not just, reduce the error of tracking or anything. We want to have some agency. We want to have some control over our sensory prediction. So more like predictive coding thing. So put together. So let's start with discussion. So what is the right embodiment, right? So, and how do we connect that to the context, right? So any views about that, right? So for example, Dana was talking about this, this growing robot inside, like, so it adjusts to the situation, right? So the intestine, when it grows, you readjust the tension, right? So, and then it is very contextual. The robots morphology being able to adapt to the context. And then Darwin talking about having very simple robots that are contextually relevant, right? So then this whole embodied intelligence thing is very contextually driven, right? Any thoughts about this?
Many topics here, Trish.
Yeah, it's many topics. Like, so I'm trying to get some hang of, like, connecting string.
So in the talk we have seen, to me there are two different cases. So one case is, for example, if you have robot moving inside the body, then you have the big question is about autonomy and adaptation. Autonomous adaptation. On the other hand, you have other kind of robot like Darwin or I are working on, so different presentation where the point is really to read what the human want and to assist the human when she or he wants. To me, this is really different. Of course, you can have a continuity, but whether you have to consider the human intention and movement or not is really something that makes the control very different, I think. Now, on the point of view of the hardware, there is no limit. Of course, then we can combine whatever we want with material, with compatible with the body, not compatible with the body, soft, rigid. Yeah, so this is different. This can be used for, according to the application.
Right.
But there is no separation. But for the control, I think it's very different whether it's a robot really to be autonomous or to work with a human.
Right.
Yeah, I think in terms of the robot that travel inside bodies, before you put the robot in the real human, you should test it, right? To test the robot, you need kind of the environment. So if the robot can be swallowed, then the digestion robots can be a platform to, to see the functionality of the robot, whether it works with inside body, in the digestion, organs, how it interacts with those individual organs at a different stage of the, digestion the process. So what happened, to the robot in the oral cavities when the robot swallowed? What's happened to to the robot in whether it gets stuck in the middle way of the esophagus? So how it deals with the gastric acids. So I think in terms of R&D of the robot, that can traverse inside body, you need kind of testing environments before you do human trials. So that I think a robot patient is a way forward.
Right.
Can I also ask Darwin, since we started from this his last talk, this discussion, if you tested a variety of tools on those people, and it would be interesting to know whether along the way they might have converged to a smaller set of tools, because they can have so many tools for so many tasks.
Yeah. So the way it happened with our project actually is we went in sort of slightly reverse. So we worked with them and asked them to tell us what tools they wanted to be doing upcoming for whatever personal reasons. So actually it was more personal motivation driven. So for example, he said, I used to do this, I now cannot do it, I have to do it again. So then we sort of made the tool. So I guess rather than the tools were designed and they chose, it was more the other way. Yeah.
Yeah. But it's interesting also, as Etienne was saying, whether it's about using that tool for a long time, whether it's about duration, that you kind of start integrating it into your own body, or it's about communication, what Etienne was doing, and how much communication and sort of control might lead to the actual embodiment of those tools, where at the point where they are no longer tools but part of the body.
Yeah, actually, I am also thinking that kind of the physical interactions. Of course, people get used to using. It's more like learning how physical characteristics. But the control itself is very subjective issues and the individual issues. So we need to distinguish that that the human is getting used to under the physical property, like passive dynamics, or like learn how to control is, I think, different layers. So embodied intelligence for physics, embodied intelligence for control. I don't know, somehow I assume that we can divide to distinguish between those two. That is my opinions. Of course, they are very much related, but still, like by wearable robotics, like using soft robotics is, I think, good for physical adaptation, but still control is like a higher layers. Just a comment.
Yeah, I see that question posted in the chat about the intelligent materials. Look, if we're going to develop the robot patient or patient robot that mimic, human functionalities, but if you look inside a robot, not the limbs. If you look inside the bodies, so most of the organs are simply musculatures, no skeleton inside. So just single-bodied musculatures. It has a functionality of sensing, actuation, and I think the materials is a key. So the material that are required to build those organ robot that able to mimic, the physiologic, the biologic process properties. I think the materials is key. But so far, those materials that apply for, soft robots, either, silicon, for the pneumatic operate systems, either, dielectric polymers. I think those materials is not the biological enough to achieve the level of the sensing capabilities, actuation capability as all human musculature shows. I think the advance in material science would be the future for soft robotics, I think.
Yeah. So I mean, of course, like it is being as biological as possible is great. But like in Kaneko's talk, she was talking about this, robo patient like simulator. So Kaneko, do you agree? Like it should it be, very close to being biological, or can we fake, as far as the trainee gets the perception and the experience? Does it matter what is really there in the robot patient?
Yeah, I think robot patients depend on the level of biomimicry. So how realistic, the biologic functionality you like to achieve. So whether it is organs implant purpose, whether it's simulators, whether it's as a mannequin so that we can touch on. I think maybe, for different type of robot, they may require different kind of material, different level of, functionalities.
Kaneko, what do you think?
Yeah.
I totally agree that we needed good materials, but how can I say it? Realistic materials are needed for the evaluation of surgical robots or other medical devices. For training, we don't need so realistic materials. So the requirement can depend on the application. And as Fumiya posted the question, I think that, in addition to the materials, actuation and the sensing is needed, and also the reaction of the human organ or human body need to be implemented. As Kenji also pointed out that human is how can I say, adaptive, in not only the cognition, but also the human body, human organs are adaptive. So it's difficult to totally mimic, but it's a very interesting research topic in the future, I think.
Or if I can add, as following up on what Kaneko said, I think for the training with patients, we can kind of discretize that kind of interaction between the material and the surgical robot or the trainee. But when it comes to testing the medical devices, especially implantable, those need to kind of understand the dynamics and the continuous process going on there. And so the material properties are important, but also mimicking physiology, as Peter was saying, and in some applications, even the metabolism of materials as they grow, they may grow. And so this becomes also bottleneck for testing the implantable, because we end up having to go into in vivo to animal trial because we don't have models that just grow, artificial models that grow.
Right. Josie has posted a question about scale, right? So, I mean, I think it also connects to Kohei Nakajima's talk about Soya computing. So, what is the right embodiment, right? So, is it like depending on the scale of the application, can we scale up the same embodiment and expect it to do the same computational role, right? So how do you deal with that? So one embodiment that is right for example, a baby might not work for another, right? A Dana application, for example.
My views regarding the embodiment. So the name of conference, the embodied intelligence. But if we put in the context of a patient robot, a robot patient, and if you look at human, the bodies, I think so far in terms of the development of a different sort of robot, the sensing, actuation, control are separate from one to another. So my understanding, embodiment should be a single musculature able to perform sensing, actuation, localized, nervous systems. So they cannot be separate from one to another. But to achieve that level of embodied intelligence, I think we need something at the nanomaterials levels. For example, the muscle fibers, and those fibers is kind of provide contractions and muscle contraction at the level of the fibers, right? It has a sensing capabilities. I think maybe nanomaterials. So if you're able to make those biologic structures from the level, at the level of atomic levels, and at the atomic levels, you're able to make it atom that is having sensing, actuation, functionalities. Then you build up, kind of embodiment intelligence, which is have similar dimensions, similar size of human, counterparts. Yeah, that's my thinking. So I think to make a breakthrough, we need some breakthrough at the bottom level of the structures. So I think somebody already been working on, artificial muscle fiber, not at the bundle of the muscle. Many of the rehabilitation robotics built on the artificial muscles. I think those muscles are not the artificial, enough, not the biologic, not the comparable to the biologic, counterpart.
Etienne had a.
Yeah, so I agree. I think rather than a different scale, it's a kind of new, actually not so new, but still new thinking about how to do robotics. I mean, so traditional robotics, you assume you have a mechanism that is perfectly rigid. You assume you have sensors that sense only one thing, that can separate the different direction. And in biology, of course, it's not like that. And in nature, in general, it's not like that. So to me, embodied intelligence is to consider this material and aspects that are in biology, of course, but that also in robotics, and to consider them in the design and also in the control. So it's at all scales.
Yeah, you're right. I'm engineer, so I regard the robots from an engineering perspective. So we are design build one. Yeah. So we are facing a lot of challenges when we design build, kind of, robots mimicking human functionalities. Yes, you're right.
Can you talk about this, biosignal coordination? So do you have any view about this, like scale, right? So like when people grow, like, do we have to have a separate, change the way this biosignal coordination should happen in your wearable robots?
I think this is related issues. I show some example of that the prosthesis with congenital amputee. So we also do that work since that even that the 5 months of the babies with that the 3D printed that the prosthetics. But not only that the control strategy, of course, that is physical interactions. Actually, main factor is the weight. So that before the babies, it feels the weighted, so they are not able to control well. But just 2 months later, so they be grown up, and also they can control the weight. So they can start to control, the intelligent control by using prosthetics. So which means that the embodiment itself is a scale, if you say about that. Now, we need to think about that like prosthetics as wearables is as one embodiment, so extended embodiment of that person. And the important thing is how they understand that embodiment itself. This is my understanding of embodied intelligence. Embodiment itself is more like physical, biological issues, what I thought about that. But the embodied intelligence, what that the person and the humans and the baby understand their own embodiment, I think can be included in the topics of embodied intelligence.
Yeah, of course. Yes. So, I mean, extended peripheral perception and actuation, like even teleoperated systems can be, you know, if you manage to couple it properly. So it is again extended embodiment or embodied intelligence of somebody who is controlling that robot from several hundred kilometers away. So there's this very interesting. So we have 2 minutes. Like Kaneko talked about this tacit knowledge of design, right? Do you have any remarks from that, like that perspective, right? So when we have like this, you know, interactions with embodiments that we think are intelligent, like, so let's say this robo patient or something, somebody has tacit knowledge about dealing with real patients, and then how do we incorporate these things to, you know, design realistic embodied robots that are, you know, meaningfully interacting with humans?
I'm not sure if I understand your question well, but you know, I say that the sensorized human dummies. So we want to put dummies on the patients, not the doctors or I mean the people who interact with the patient. We want to implement the sensors for the patient because that's a way to understand the tacit knowledge. You know, for the patient, it doesn't matter that patient is touched on the right hand or left hand. The reaction that the action that the patient got from the outside is important. It's a real tacit knowledge. So the view from the patient is important rather than the view from the surgeon
Right.
when we
Okay.
discuss the tacit knowledge.
All right. Yeah, that's great. So we have come to the end of this panel discussion. So then we start 3 breakout rooms. You can go to these breakout rooms and then join these interesting discussions, and then come back at 1, and then we do a panel discussion. Thank you very much. Thank you very much, all the speakers.
Thank you.
See ya.
Thank you very much. Bye.
Bye.
Yeah, thank you for coordination, Tristan.
Oh, no. Yeah, thank you. Thank you.
Trish, bye-bye.
Yeah, bye-bye. Yeah, nice seeing you, Doug.